Hello friends, today we are going to perform the experiment of diffraction grating. Using diffraction grating, we are going to determine wavelength of visible light. For that, this is diffraction grating given to you. This grating consists of 15,000 lines per linear inch. So grating element will be 1 inch divided by 15,000, that is 2.54 centimeter by 15,000 will be your grating element. Grating element is nothing but smallest element of diffraction grating. Basically, diffraction grating is nothing but an arrangement which consists of many parallel slits with equal spacing. For example, in given diagram, in the diffraction grating, there are 5 slits or 5 rectangular openings having slit width A and distance between or opaque space between 2 consecutive slits is B. So A plus B is the smallest element of this grating. If you repeat this A plus B 5 times, you will get complete diffraction grating. And in the experiment, we are going to incident white light on this diffraction grating. All of you are aware of diffraction of light. Diffraction of light is nothing but bending of the light waves around the corners of an obstacle. So when white light is incident normally on this grating surface, all 7 constituent colors of white light get separated from each other in the order Vibjot. This is called as dispersion of light. So you get a spectrum: violet, indigo, blue, green, yellow, orange and finally red. In the experiment, we are going to find out wavelength of violet color and green color. Condition for maxima is A plus B sin theta is equal to plus or minus m lambda, where theta is angle of diffraction, m is order of diffraction, m will have value 0 is also included in this order, 1 and 2 onwards. So for m is equal to 0, you will get white band again. There will not be diffraction because light is traveling in straight line path. So all 7 colors will merge into one to obtain white band at the center. This is 0th order. M is equal to 0 here. When you substitute m is equal to 1, this equation will become A plus B sin theta is equal to plus or minus 1 lambda. So as lambda varies from violet color to red color, angle of diffraction theta will also varies from violet color to red color. It means that all colors will get separated from each other because every color will have different angle of diffraction. Here, angle of diffraction is nothing but angle made by violet color with respect to incident light direction. So this will be your theta V, and in the experiment we are going to measure this theta V with the help of optical spectrometer. This instrument is called as a spectrometer. There are 3 main parts. This is collimator. This is screw to adjust slit width of the collimator. This is focusing screw of the collimator. This is prism table. You can keep your prism, or in our case diffraction grating, in this slot given, and this is telescope. This is focusing screw of the telescope. You can see reading of the spectral line angular displacement using these two windows. One window you can call as window A, opposite window will be window B. So there is circular scale, main scale is circular one because we are going to measure angle with the help of this optical spectrometer. So your first job is to find out least count of this spectrometer. Least count is given by smallest division on main scale, smallest angle which you can measure with the help of main scale, divided by total number of divisions on vernier scale. Inner one is the vernier scale, outer one is the main scale. Here you can see there are 30 divisions on vernier scale. Total number of divisions on vernier scale are 30, and smallest division, if you observe carefully, you will see that smallest angle which you can measure with the help of main scale is 0.5 degree. This is the lamp and lens, magnifying lens arrangement provided to you to take the readings. You have to do for arranging slit width of the collimator. You have to collimate the beam. So that width, slit width should not be too narrow or too wide, so that your spectral lines will be also sharp spectral lines and error in the measurement will get reduced. To find out least count of the spectrometer, you can apply this formula. Least count of optical spectrometer is given as ratio of least count of the main scale, that is smallest degree you can measure with the help of main scale, divided by total divisions on vernier scale. Your least count will be in degrees. Then you can find out total reading using the formula vernier scale reading multiplied by least count in degrees plus main scale reading in degrees. That will be your total reading. While finding reading with the help of spectrometer, you have to arrange vertical crosswire of the telescope tangential to outer edge of particular spectral line. Here we are finding angle of diffraction for violet color. So vertical crosswire of the telescope should be arranged in such a way that it is tangential to the outer edge of the violet color. And you have to take the reading from both the windows, window A and window B. The difference between the readings windows will be exactly 180 degree because these two windows are exactly opposite to each other. Angle between these two windows is 180 degree. So in this way you can adjust vertical crosswire of the telescope tangential to green color also. Take the reading from both the windows, window A and window B. Substitute angle of diffraction in the formula. A plus B is known to you. M is order of spectrum. This is first order spectrum. Near to 0th order, you will get first order, then there is a dark space, and then you will get second order spectrum. You will observe that separation of colors in the second order will be larger than that of first order spectrum. Now, once we have adjusted slit width using the screw, now next job is to do focusing of this collimator with the help of the screw. So see only through the collimator and adjust this focusing screw so that you will get well focused slit. Then only final pattern will be focused one. So we have done with this focusing of the collimator. Now see through the telescope and adjust focusing screw of the telescope. You will observe central white band because we have not kept diffraction grating. Now, once this initial arrangement is completed, you can keep this diffraction grating in the given place. Make sure that grating surface will be perpendicular to the incident light. This is the direction of incident light. This is the surface of the grating. So incident light is falling normally on the grating surface. Now observe through the telescope. You will observe central white band again, 0th order diffraction. Then shift this telescope to left hand side with certain dark space. You will be able to observe spectrum of violet, indigo, blue, green, yellow, orange and red colors. If you shift this telescope on extreme left side, again you will observe certain dark space because condition of minima is satisfied here, and then second order diffraction. You will observe same sequence of colors. So this is second order diffraction. So first you have to observe these spectra, two on left hand side. Similar type of spectra will be there on the right hand side also. Exactly mirror image of left hand side. Dark space, then violet, indigo, blue, green, yellow, orange and red. Again dark space and second order violet, indigo, blue, green, yellow, orange and red. Once you identified all these four spectra, you have to arrange vertical crosswire of the telescope on first order green color. While arranging, vertical crosswire should be tangential to outer edge of the green color. You have to fix this screw. Once you fix this screw, telescope will not move and you will get correct value of the reading. Take the reading from both the windows, then adjust, loose this screw and adjust the vertical crosswire of the telescope tangential to violet color. Take the reading from both the windows, window A and window B. Then shift this telescope to right hand side. On the right hand side you have to adjust vertical crosswire of the telescope to the right edge, right outer edge of the violet color. When you complete first order, there will be dark space again, and you will be able to observe second order spectra. Second order spectra will have less intensity as compared to first order. Sequence will remain same: violet, indigo, blue, green, yellow, orange and red. So this will complete readings for all spectra, first order as well as second order, violet and green color.